Hello.
Elle a dû déconnecter.
Ah, d'accord, ok. J'ai mis plus de participants à ma visu pour voir plus de monde.
Hello Xavier, salut.
Ouais,
Tu
c'est
peux
quand
fermer
même plus de monde, quoi.
ton micro. Thank you. And can everybody mute? Would be great. Hi everybody, nice to see you. Sorry for the small delay.
Legal, parabéns aí. Obrigado, viu, pessoal? Até mais.
Okay, so hello everyone. We would like to start our next Prometheus Unveiled workshop today. For today's agenda, I will briefly pass the floor to Matthias de Beeve, the president of Prometheus-X and CEO of Visions, who will present the overall visions and the Prometheus-X approach. Then I'd like to do an overview on the Prometheus-X architecture. I'm Laszlo Gönci from Budapest University of Technology and Economics. Then we will pass the floor to Felix Ball at Visions, who will do a technical presentation of the components, also accompanied by a running demo of a configuration of a data exchange and concrete data transactions. So he will show the running implementation in a real operational environment at Visions. Then we will have a Q&A session. So I'd like to ask Matthias to do your introduction.
Thanks, Laszlo. So hi everybody, very happy to have you here. Today it's really to get in depth into some more technical elements and how it all works. So I'll just be very short for those that don't know yet Prometheus-X. We're working like all of you on enabling this trustworthy data sharing and on enabling people to control their data in data spaces so that they can have more sovereignty, more freedom, but also better services, and organizations also to share and exchange their data. And for this, I'm going to go to the next slide, Laszlo, thank you. For this, Prometheus-X was created, and it unites a lot of different technology, infrastructure partners, organizations that believe in this vision and this mission, and that want to collaborate together to create a common and human-centric data sharing infrastructure. So we have about 19 of these partners that are building the infrastructure and using it. We are working on 20 components to enable this open source infrastructure. And all of these partners are also working in concrete use cases to deploy this human-centric data sharing in the skills domain, in the media domain, in the smart cities domain. So there are about today 200 organizations using directly or indirectly this infrastructure to build great use cases across 10 EU countries. And so that's what Prometheus-X is about, is to unite a community of people, of organizations that share the same vision and that want to collaborate on a shared infrastructure. And so if you're here today, is that either you're part of it and you'll learn more about how to concretely implement it, or you want to be part of it, and I hope you will join us in this common goal and construction. So if we go to the next phase, what Prometheus-X does, on the technical aspects, it will be more defined, but generally, Prometheus-X really provides, and all this community collaborates on some core open source components that then the different partners can come and deploy and use to connect different data AI providers and to deploy these human-centric and sovereign data exchanges. And so here, today, we will show the demo through the Visions Trust operator and data intermediary that integrates these components, but we have many others. So if we go to the next slide, so there is Visions Trust. We connect a lot of different providers, mostly in the skills and education domain. There is Merlot, which is also working in the skills and education domain, more in Germany. There is the French Ministry of Education that is also working and integrating some components to enable cool use cases. We have in other domains as well. So in the tourism data space, some partners, in the media data space, some partners, and even more internationally in South Korea, some partners that are working to deploy such use cases and this infrastructure. And all of us are working, and we have many more partners as well that are contributing and creating use cases, but all of us are working towards this common goal, towards this common infrastructure to build, in a sense, a new layer on the internet that is more trustworthy, more decentralized, and more human-centric. And we are thrilled to present to you today concretely how this infrastructure works, and we hope you'll use it and be part of this great community.
Okay, so I'd like to briefly introduce the overall architecture of PROMETHEUS-X. So we are building on open source building blocks, which can be put together in different combinations. We'll show some of these possible combinations with which you can connect to the data space without a dependency on a concrete infrastructure. And as Matthias mentioned, we are focusing on personal data with a strong focus on putting the control to the hands of the user and to evaluate the trustworthiness of both the data and the algorithms used in the data space with support of decentralized approach as well. And from this general architecture, there are a number of already available blocks. There are blocks which are already specified and will be available by the end of the year. We will concentrate on some of these today, the core blocks, which enables you to connect to the data space. We have a collection of these blocks, and there are some main usage scenarios for them. Such usage scenarios are, for instance, about to manage skills data or to manage and analyze learning data and learning records. And to say a couple of words about the overall architecture, there are the core blocks, and there are blocks which add additional functionality to this core in order to create a trustworthy layer and architecture. You will see some of these core blocks today, so these will be presented by Felix. There are blocks which are created for supporting trustworthy data sharing and add the decentralized approach to the project, both in terms of AI training and AI and data processing, and the assessment of AI algorithms and services to be used in the data sharing scenarios. There are blocks which are about transforming and managing data from different domains, basically here mainly from the skills and learning domains, but some of them can be applied in other domains as well. And these are meant to help the users and the organizations to share and manage their data across different service providers. There are blocks which are quite generic purpose utility blocks, like the data value chain tracker, which is meant to support different business models on top of data sharing and incentivization and valorization of different partners in the data sharing scenario. The veracity assurance block, which checks the quality and the veracity of the data and the results produced by different blocks, components, and services of the data space. And the visualization block, which helps to make intuitive and yet privacy-aware visualization for different users. And if we look on some of the scenarios we are working on, one example is a service chain to support the analysis of learning records, where, for instance, if someone wants to get some recommendation to her own personal learning data, which is stored at a personal learning record store, then this will be managed by using different data entities of the PROMETHEUS-X data space connector, which will be presented. These connectors will communicate with each other and with the data intermediary and the core components in the data space, and will support the implementation of different services, like, for instance, using other learning records and some service, like, for instance, a game recommendation service, which then returns data to the user. During this process, there are different checks of the contract and consent component to meet the predefined requirements in terms of conformance and privacy as well. Another example is the skills data visualization example, where different entities can collaborate to support some visualization service at the end of the user's device. We need the visualization component for this. We need a component which translates and manages different types of skills data. And we need the components which check the quality and kind of value of the data being shared in this scenario. And different providers can connect to this data space using the PROMETHEUS-X data space connector. And now let us see how this works in action in a real operation and environment. So I would like to ask Felix to take the screen and do the presentation about the actual working core components.
All right, thank you, Laszlo. So start by sharing this. All right, so hello everyone. My name is Felix. So I'm the current CTO for Visions. So I work with Matthias that made the short presentation before. We are in charge within PROMETHEUS-X of several of the building blocks that are being defined in here. So mostly the contractualization one, the catalog one, and the consent service. Consent was actually one of our main focuses before PROMETHEUS-X even existed. So we're trying to bring our expertise on the subject inside of PROMETHEUS-X. What we'll be showing today and discovering together is, first of all, how the data space is set up with these core components, and then also how participants can actually communicate with the data space. So I have a quick agenda here on what I'm going to talk about today. First of all, I'm going to do an overview of these core components. Now, we've been showing these components in other events, but it's very important to at least get a high-level comprehension of them in order to understand what's coming next in this agenda. We'll look at the practical example through the Visions Trust implementation. Visions Trust is actually running some of these core services behind the scenes and is enabling the first actual implementation of some of the building blocks defined in PROMETHEUS-X. So it's a nice way to find out things. And then we're going to look at how participants actually join the data space. So everything from onboarding the data space to registering the different assets to the catalogs, etc. Everything about contractualization, and then going to the technical onboarding. So the technical requirements for participants in order to take part into the data space, such as setting up the connector and linking up the connector to the resources that participants may have. And I'll end up with some technical demos and use cases showcasing both a data exchange and a consent-based data exchange. So you've seen this before, just to go over it once more. So it should actually be the other way around this picture, but that's fine. If you look at the bottom with the digital commons layer, this is where many of the entities that work on the data space define the rules and the specifications and technical standards that should be used within data spaces. The role of PROMETHEUS-X in the infrastructure layer is to define the open source code for these specifications and align as much as possible to what is defined in these higher up entities. And then on the data and services layer, this is actually a two-layer in one. We have the data intermediaries that are the people running the instances of these building blocks and that are enabling the services for the different data providers, AI providers, and service providers. So Visions Trust that we're going to be showing afterwards is one of these data intermediaries running, for instance, the consent, contract, and catalog building blocks that are defined within PROMETHEUS-X. If we look at the same kind of picture, but with actual PROMETHEUS-X components, We have at the high level here the reference models, which is basically inside PROMETHEUS-X registry or repository of models that can be reused throughout the data space. So this is where things like data categories, service categories, different kind of pricing models, business models can be defined, but also where actual rule templates can be defined to be reused easily inside of contracts whenever participants are negotiating on the access and usage of some of their resources. So in the infrastructure layer right under it, we have any amount of basically data spaces that can run these PROMETHEUS-X building blocks and run instances of them. And we have in each one of them a catalog registry, which is an entity component that relates to the reference model, synchronizes with the reference models, but also allows for customization and specific needs of a data space, basically. So the catalog registry is going to be tailored for the data space and providing the right information for that data space directly. And at the bottom, we have a more adoption, implementation, integration layer, which is targeted towards participants that are going to be wanting to communicate with the data space, and that's revolve around basically instantiating a data connector for themselves and being able to communicate with the data space. So quick overview about the different components I just talked about. First of all, the catalog registry. So as I mentioned just before, it is synchronized with the reference models and provides some information that streamlines a lot of processes within the different services inside PROMETHEUS-X. So if we take, for example, the catalog registry providing information to the catalog, this is mostly going to be things like I said, right, the data categories, service categories, business model, pricing models, and a lot of different roles that participants can have. Many things that can be configured when participants are configuring their assets, their projects, and things like that inside of the catalog. And on the other side, the registry provides to the contract these rule templates, so rules that are defined in an ODRL policy template, which allows for easy integration and injection of these policies inside of the contract to avoid as much as possible participants having to go in and get their hands dirty and manipulate ODRL, which sometimes can be a very big overhead and very complicated when on certain use cases. Okay, so next we have the catalog. The catalog is one of the most important core services because it's kind of the entry point and the easy access point for participants to get into a data space. It is where most of the assets and most of the participants, most of the projects are going to be defined. And it also allows for discoverability, of course. So new participants can easily be onboarded and discover what's available inside of the data space. But it also allows for management of these resources and management of projects and, most commonly called ecosystem use cases. So data space use cases, sorry. Which I'll get into in a minute. But yeah, so it's an important registry of information, of metadata that is used by all the participants to both discover and negotiate and find interesting resources to configure data exchanges that can be enforced with the contract afterwards. So quick words about projects I was just mentioning. PROMETHEUS-X is bringing this aspect of data space use cases, which is the official term inside of the data space support center, which is essentially a sub-data space of a group of participants evolving around a similar use case, led by usually one participant, which becomes the orchestrator of that use case, and where several data exchanges are set and defined for the different members of the ecosystem, basically to be able to enforce. So one of the benefits of this approach is that it avoids having individual one-to-one contracts between each and every member of the use case, and instead we can have one multilateral, basically, contract that rules all of the data exchanges that happen within the bounds of this project. So it's a very interesting feature, and one of the things I'll be showing in the diagrams of the data exchanges later on. But it's one of the important aspects of the PROMETHEUS-X catalog. Then we have the contract, very important component, because without the contract, you can't actually have a data exchange run. So Of course, the component allows for contract generation. We have two types of contract that we support. So the peer-to-peer contracts, the natural bilateral one-to-one contract that is relatively standard today. And we have these ecosystem level contracts, which are these multilateral contracts for specific projects. We also have some components that handle the injection of the different rule templates defined inside Prometheus-X directly into the contracts. So this is a helpful tool to allow participants to not have to, like I said before, right, manually configure their ODRL policies for each and every one of their resources. And of course, it's a component that allows for contract signature, which leads to having a contract that can be enforced in data exchanges and yeah, run the actual data exchanges. So a quick word about these rule templates. If you're a little bit familiar with ODRL, you might recognize the format here. It's a custom template that we made on top of ODRL in order to provide basically this well, default templates to use and easily negotiate on during the negotiation phases to avoid participants having to rewrite all of this by hand. But essentially, this one shows a very, very simple policy, which states that the data, the resource can be accessed without and used without any restrictions. So it's a very, very simple use case. If I were to take a more complicated one, it wouldn't even fit inside the screen. So this was why we're taking the simple one. But yeah, it's one of the examples of what can be used with this rule templates and policy injection inside of the contract. All right, so very quickly, because I'll get into this more in details, but the contract is negotiated two ways. So for bilateral contract negotiations, very, very simple one, where you have two options. Either you go on the catalog and you have a streamlined version of the notification sent to each party when one party is interested into a contract, the other one receives a negotiation offer, and they negotiate until they reach an agreement. And we have the more use case level contract of multilateral, which is a little bit different, in which the use case orchestrator is the one handling most of the access rights to the project by inviting different participants to join the ecosystem for specific offers and resources that this participant might have and might be beneficial to have inside the project to be used by all of the members inside of the project. But essentially, negotiation phase is kind of the same in both. They need to agree on the usage of the offering and the usage of the resource, and define the pricing and policy options on those elements in order for the contract to be validated and be used afterwards inside of an actual data exchange. Okay, and then last but not least, we have the consent. So consent is going to be introduced for every data exchange that requires personal data. If your data resource is tagged as either being personal data, or if you have a service or data processing service that is tagged as processing personal data, you're going to be requiring the need of a consent given by an individual in order to validate a data exchange for that specific resource. This is where the consent service comes in. We can most commonly we can englobe this consent service into the personal data intermediary concepts. But it essentially offers the individuals a way to handle their consents easily and handle their authorizations across the data space on how their data is used, by who, for what purpose, etc. But so there are a lot of mechanisms inside to verify the validity of the consent, the lifecycle of the consents, and provide a lot of options for the individual to easily grant, revoke his consent, etc. It's based today on an ISO that came out last year actually, on the consent record information structure for the different models of the consent receipts, consent records, and the life cycle of the consent. And yeah, it is an essential component whenever we're talking about personal data. If we could quickly look at a very simplified architecture here for the consent service and how it interacts with the other components. So say the individual here is wanting to grant his consent on the exchange of data between these two participants. First of all, and I'll get back into this later, but there needs to be a contract that exists between these two participants in order for the consent service to display the information about what data you're actually going to be sharing within this exchange. But so once the user gives his consent, there is a communication between the consent and the contract service in order to verify if the contract between the participant is still valid, and run some verifications on it. And if it is valid, then the consent service is going to be able to provide the consent to the participants in order for them to trigger the data exchange based on the individual's consent. I'll get into more details into the actual protocol of this later on. I have a sequence diagram that explains things a little bit more in depth, but this is a high-level view of how the consent communicates with these participants. Just before we get into the Visions Trust implementation, so this, you can find all of the documentation and the code, actually the open source code for the components I just showed within the PROMETHEUS-X GitHub repository. But essentially, you'll have this information after the workshop to look into if you want to. And one last thing is that, yeah, we have a lot of partners that are actually, some partners that are actually implementing the PROMETHEUS-X building blocks, but we have others that are also using the Visions Trust implementation. For example, a lot of edtechs, a lot of services that are using the services that are provided and implemented by Visions Trust in order to run their different use cases. So there is already a little bit of attraction on those services. So yeah, let's just jump into the practical example on Visions Trust. And just before I get into the actual websites, I want to jump into here to talk about a little bit of the architecture behind Visions Trust in a high level. I'm not going to get into too much details, but just to explain how these services were instantiated by Visions Trust and how they are run. So at the top level here, we have our PROMETHEUS-X with the different services, so the open source code, not ran by PROMETHEUS-X, but provided as in building block. And Visions Trust here has different servers for each of these services. So for example, we under the API of Visions Trust, we are running an instance of the catalog. Inside of the contract of Visions Trust, we're running an instance of the contracts, and same thing for consents. We made here the decision to push them to independent servers. We just cloned the code inside of these servers and decided to run them like that. There's a lot of options to run to instantiate these components. You can either use the code itself, you can use Docker if you want to. There are configuration inside the repositories to either use Docker, either use the code, or use a Terraform script if you want to. So there's a lot of options to choose from. We just decided to install the code directly on some compute instances if you want. But essentially, so these are instances of these services that we are augmenting most of the time to fit the implementation's needs. Visions Trust as a service and as a business also has some implementation needs, and so builds some tools upon and above these services. And this is the case for anyone who would like to implement these PROMETHEUS-X services. Someone could decide to, for example, use only a contract and instantiate a contract server somewhere, and build an interface based on a solely contract management inside of the data space. Same thing for consent, same thing for a bundle of these services. And as Laszlo was saying before, we have a bunch of other building blocks inside of PROMETHEUS-X. And so anybody can decide on what to use, what to build on top of it, and what to provide inside of the data space. And so one other thing that's inside of the realm of Visions Trust, let's say, is the provision of this visionstrust.com application, which is a user interface built on top of these services, which allow for easy interaction with the different services for participants and users that might not be fully technical. So this is what Visions Trust provides in the architecture. Now, if we just look a little bit under at the participant realm, so of course, we know as the technical people that the realm of an organization for the technical aspects is much, much bigger than that. Usually we have a bunch more services, a bunch more elements inside of it, but this is more of the bare bones components that interest us today. So we were supposing here that this participant is both a data provider, so he has data that he can propose to the data space, and he also has services that he can propose to the data space. He needs a way to communicate with the data space and the data space services. And this is done through the data space connector. Data space connector is showed here as being on the edge of the participant realm. This is because he can decide basically where he wants to instantiate it. It can be on-premise, it can be on a cloud, it can be a SaaS providing a connector for him. This is fine. The only thing that is important for the participant is for the connector to be able to communicate with him and to communicate with the infrastructure services on top. One thing to note is that the data space connector is not something that is mandatory, but is highly recommended. The implementation of a connector, well, first of all, it's an open source project, so anybody can fork the project, do something else with it. But any participant could decide to implement each and every API of each and every service and the security checks on their own. But this is something that is not, that is a little bit of a hassle to do. And so the connector is usually a recommended approach for both adoption and well, control and verification purposes. So that's that. And you can see in red here, just some very simplified interactions that the connector usually has with these different services. So it usually connects to a catalog to synchronize the local catalog available for the participants to the centralized catalog. It verifies contracts, signs contracts, negotiates on contracts, etc. with the contract service. And for the consent service, it usually either receives consents to trigger data exchanges or verify consents that it's received. Yeah, verify consent and trigger data exchanges based on consent. So this is the main thing. Now, what's interesting in this implementation is that over here we have our admins. These admins might not be technical people, and so for non-technical people, they need a way to tell the catalog, well, I have these kinds of resources. I want to contractualize on this resource from that other participant because it's interesting for my business use case, etc. And so this is why we have this interface, which allows anyone to come in and basically configure their resources, configure their contracts, configure their projects directly from a centralized interface that communicates with these different services. And yeah, this basically avoids for the participant to have to run API calls to this service, run API calls to this service, and run API calls to this service to do all of the things that you could do on an interface directly over here. But this is implementation specific. This could be done any other way by any other participant or any other actor or data intermediary that would like to instantiate these services for themselves and to provide them to this data space or another data space or whatever data space. Okay, so just a quick word about resources. Sorry, I'm going to get back into this in a minute. So just preparing the field here. Resources, when I talk about resources, it's representing basically the metadata of the data available inside data sources or the metadata that represents the mechanisms and the way the services, APIs, AI services work for a participant. The catalog over here, and from PROMETHEUS-X also, is essentially a metadata broker, right? The values of the data, the actual data is never sent to the catalog. We're only registering metadata and we're only working on metadata, and the data space connectors themselves are going to be the ones exchanging the data after resolving the contracts, verifications, etc., etc. Okay, enough talk for now, enough diagrams. Let's look into vision stress. So I'm logged in here as one of our test services that I use a lot for demos. So you might see a little bit of data that might not make a lot of sense, but we use it a lot for these kinds of presentations. I'm not going to go over most of the implementation specific stuff and more of the vision stress specific stuff, but I'm going to go over what needs to happen for a data space participant and what actions he needs to take in order for him to configure his participation within the data space. So it's easier to see with this vision stress interface, but it's actions that need to be taken by anyone in any kind of implementation of the catalog, contract, etc. So first off, the offers. Inside the offers, I can, as a participant, as a data provider or service provider, register some resources that represent my data and register some resources that represent my service. Remember what I said earlier, the resources are the metadata that talk about basically my data resources and my services. So over here, for example, if I go in and create a new resource, I have all of this form that I can fill in. This can be done through API, of course, and it's mostly going to be happening like this for other implementations that don't have a UI on top of it. But this is here to help for adoption and have anyone that is probably non-technical also be able to communicate with the data space. So very generic information on the resources that they can register. You can also register one very important aspect is to say if this actual resource is going to be including some personal data, because if this is tagged as personal data, then we are going to be needing the consent whenever this resource is going to be exchanged. And then there's a more technical tab in here, which I'll get back into at the right time, because right now it'll be confusing if I go into right now. So we can register data resources. We can also register service resources, which is the same principle. It's just that it's representing a software, an API. So there's some fields that are a little bit different, but essentially it's exactly the same thing. And as for data that you register, when you register a service that is actually processing personal data, you're also going to need to specify if or if not it's actually processing personal data. Because if it is, then you're also going to be needing the consent in order to enforce a data exchange whenever this resource is included inside of a contract. That's the basis. Now, we have our resources. One point about resources is that they represent somehow the personal catalog of a participant. Resources themselves are not made available directly to the other participants inside of the data space. They're not made available directly to the data space as a whole, because what is made available is the offers, and in a more technical term, the real actual term for this is service offerings. So service offerings are actual aggregations of resources of data or resources of services that are usually they usually have some more information about the actual business product on it, so pricing information, policy information, etc. And this is the element that is going to be shared among the catalog and upon which other participants are going to be able to negotiate on in order to build out the contracts. So we have a bunch of demo here. I'm just going to go into one demo PROMETHEUS-X Unveiled here. So this is one of my offerings. And inside of it, I can set a bunch of information regarding the pricing. I can set the usage policies that are going to be applied for this offering. So in here, by default, it's going to be a no restriction policy, but we can have, I could decide to have a more customized policy. So something like a time period on the access of this this resource, which would block the access outside of the time period. We had to have a count policy, which would block the access after a certain amount of times it's been used. But these, again, are templates. So whenever I select one of these, it's not going to be configured directly. It's going to be configured when I'm going to have a negotiation with another participant. And this is where we're going to decide what values for the policy is going to be applied, like what is the time period, what is the amount of time it can be used, etc. And finally, we have the offers contents. The contents of this offering, meaning the different resources that are aggregated together to be able to provide this resource to the catalog. And this can be any number of resources because it's an aggregation. So here I have just one, but I could easily add some more that I already have or create some on the fly. But essentially what I'm doing here is registering the core information that is going to be provided to others inside of the catalog. And without this, I basically cannot have contracts for data usage, because data processing, contracts are made on top of a data provider providing data and a data consumer providing a service. So if I want to contractualize with someone, I have to be on either side of it. So I need at least one service offering of data if I am a data provider, and I need at least one service offering of service if I'm a service provider in order to communicate and negotiate with other participants. All right, so this is for registering information. Now, once I have registered this kind of information, what I can do is go inside of the catalog and browse the information that's within it. And if I find something that's interesting, so here is from another one of our test accounts, I can analyze this offer, of course, and I can go ahead and try and use this offer. When I want to use this offer, what it's going to be doing is instantiating a contract negotiation process between me and this provider for the access of this resource that I'm seeing on the screen right now, and one of my service offerings that I would have configured previously. So if I jump back here for a minute on the actual diagrams and what happens behind the scenes. So we have two types of contract negotiations. We have the contract negotiation for the peer-to-peer contracts, so the one-to-one bilateral contracts. And we have the contract negotiation for the ecosystem level contracts. For the peer-to-peer contract negotiation, it's very simple. So the first step is how I showed you before. I'm browsing the catalog, I'm finding a resource that's interesting, and I want to request the access and the usage of this resource. The data consumer, or the other party, basically, is going to be able to review this usage request, so the negotiation, and is going to be having the ability to do two things: either renegotiate on them or accept the negotiation. If he renegotiates, we can enter a loop that can go on and on until both parties accept and stumble upon an agreement for this specific use case. But it's a loop basically until both agree, and at the end of the agreement, they both sign the contracts, and we end up with a signed contract that can be used inside of a data exchange and understood by connectors and by the contract service as being a valid contract. Now, on the other side, for the ecosystem, it's the same kind of process. It's just that the difference lies in how the actors that the parties that take place into the negotiation. So on one side, we're going to have the project leader, which is the orchestrator of that use case. And on the other one, we're going to have any kind of provider, a data provider or a service provider. And what happens is usually the project leader is going to be looking into the catalog for data or services that could be interesting for his project to have. But he could also be looking for actual participants that he knows are interesting because they provide a lot of data or types of data that match with their project. So, but basically the first step is still browsing, discovery, or recommendations. And what happens then is that whenever the leader makes the request to access a resource for his projects, he's actually doing two things. He's making the request for that offering, but he's also inviting this other participant inside of the project that he owns. So when the other party is going to be reviewing the negotiation, he's reviewing both the access to his offering for that project and his participantship inside of the project. And afterwards, it's the same kind of process. They're going to be negotiating until they stumble upon an agreement. And once they have an agreement, this is one of the other differences. The participant is going to be signing the contract that already exists for the project and is going to be added as a member of this project, so this ecosystem. Once he's added as a member of this project, he can then basically trigger data exchanges with other members of that same project that also have signed the contract. So this was what I was mentioning earlier about the ability to have one contract for basically more than one exchanges within the bounds of a single project. Okay, once participants have an actual contract that is signed, they should be able to enforce the contract and run data exchanges. But to do that, they need to have the data space connector configured. So very quickly here, there are two steps in setting up a connector. The first one is choosing where to locate it, where to host it. This is, as I was saying before, up to the participant to decide. It can be on-premise, it can be on the cloud, it can be anywhere that is available for the participant and available for the data space. It's important to, since it represents the participant inside the data space, it's important for it to be available by the data space infrastructure services and also by the other participants in the data space. So first step is to decide where to host it. Then it's about configuring it and pointing it to the right services. One note I want to mention here is that in the current Prometheus model, we are working with a centralized approach. This is evolving, and we're moving to a more decentralized approach. But currently, the way you specify and configure your connector is you're going to be instantiating it and telling your connector what catalog service you're going to be using, what contract service you're going to be using, and what consent service you're going to be using. And this is important because this is the connector basically needs to know what service he's going to be using, but the service and the infrastructure also needs to be able to know who the data space connector is and who the participant is for that connector. So data space connector basically acts as somehow the participant's identity inside of the model right now. One other thing that they need to configure inside the data space connector is, well, if we take a look here, so admins are going to be, or anyone is going to be registering on Visions Trust. When they do, the participant is going to be registered inside of the catalog, the centralized catalog. When they're registered inside of the centralized catalog, they're going to be receiving some API keys that will be used by the connector or the participant to make some authenticated API calls to the system in place. And so the connector will be needing to set up in his configuration the 3 endpoints that he's going to be talking to and the keys that he's going to be using in order for authenticated calls to these services. Now, it's a very minimal setup, but it's a required setup in the centralized approach today in order for everyone to know about everyone, basically. So this is the first step about instantiating, setting up the connector. The second thing you need to know and do when you're working with setting up a connector is you need the way afterwards to specify how your connector is going to be interacting with your resources. And so this is made by setting the technical metadata of your resources inside the catalog. Basically saying, my resource, basically telling your connector that this resource should be called at this location for these types of credentials, if there are any. And basically for your connector to know how to communicate with the resource, how to get the data, and how to push the data if that is an API or a service in place. All right, so before I jump into the technical representation of the resources, I want to show you this over here. So this is an example of a connector that we are running for our test purposes. Here you can see that it's running on Heroku, for example. This is a choice we made. It's one of the options. You have many different options for deploying the connector. As for the other services, you can deploy through Docker. You can have a bunch of different options. You decide where you want to deploy and publish your connector. The only thing that needs that should be done for the connector is for it to be available through the internet, so for other participants, and have a secure encryption system to be able to communicate with the rest of the data space entities. And so here is just one example of one of our connectors running that is configured for the test participant I was showing you on Visions Trust before, and is accessible to the rest of the world, basically. Just to showcase real quick, Visions Trust, here we have a very simple interface that allows you to see if you have configured your connector correctly. So this connector here is configured to point to the Visions Trust services. And once it's correctly registered, then the system is able to tell you, well, okay, I know that your data space endpoint basically is this endpoint for your data space connector. And so, yeah, this is one example of a connector running in production for which we are running data exchanges and helping other participants exchange with this test service to set up some of their connectors themselves. Okay, so let's go into this diagram, and afterwards we're going to show a little bit of concrete operations. So how does a data exchange happen? First off, as I was saying earlier, both the data, so there needs to be an existing agreement between the data provider and the data consumer. Without this agreement, we cannot have the data exchange. The process will be blocked. The contract will not be able to be verified on the contract service. So it cannot work without these systems. So this is assuming you already have a contract that has been negotiated between the two participants. Now, first step of this is as defined by the IDSA protocol for transfer process or any kind of actual data request. It's usually the same way. The data consumer is going to be making the first request to the data space connector of the data provider. And for that, it's going to be providing the contract that they have been negotiating on before. What happens then is that the contract is sent over to the data intermediary that has the contract service, where the contract is verified and where the policies are sent back to the data space connector for them to be verified and enforced directly by the connector. And then what happens is two things. The first one is the policy enforcement point, which is where and how the data space connector is going to be basically validating the different policies that are set inside of the contracts, and yeah, making sure that they all are valid and that the data can be accessed by this consumer. And the second one is the data resource endpoint resolution. And to explain this, I'm going to go back into Visions Trust and show you a little bit more about the technical metadata that should be put inside of the resources. So I mentioned earlier that there is this tech tab here, which is basically for what we call the representation of a resource. It's called a data representation or software representation, depending on if it's data or software. But it's basically a representation for the connector to know how to communicate with the resource. So basically, I can say that in here, my resource is available at this example endpoint. And this will allow the connector to know when this resource is involved inside a contract, okay, this is where I should go and get the data in order to give it back to the consumer later on. So this can be anything. This can be any kind of data source. It can be a controlled data source that's in the realm of the participant. It can be an external database. It can be a bucket somewhere. It's just something that needs to be available through this API with or without credentials, optionally. And if you have credentials, I'm going to get back into this afterwards, but if you have credentials, you can set them also on your resource in order for your connector to use these credentials in order to build up this API call. So this is the basics, telling your connector that this resource is available at this endpoint. Now, if you have security, authentication, something on this endpoint that your connector should know about, you have two ways to go about it. Either it's something that's relatively static and you can alter your connector and set it up in your connector yourself. But there is also a way directly included inside the connector is with these credential identifiers. A credential identifier is a little bit complex, so I'm going to go into details about it afterwards, but is basically a piece of information that is known by your connector and only your connector to be able to resolve a credential configuration that should be set inside of the API call that's going to be making to communicate with the resource in question. So just going to show an example out of this. This is going to be a little bit more technical, but here I'm going to be communicating with basically my my connector that I showed before and setting up a new credential group, basically. So how it works is that I can set up whatever type of header I would want to have added inside of the API call made by the connector, and any kind of super secret value for that specific header. So this header could be something very standard, like authorization or a next API key or some sort. It's dependent on what you need and what your connector requires to make an authenticated verification call to the right resource. But so I made one earlier here with this information. And so it stored a new key. new value, which is a value of a head. So it's a header and value of that header group. And I'm also provided with this ID, which is stored inside of my connector that only my connector knows how to resolve. And this is what I can then set up inside of my resource representation over here to say to my connector, whenever you're communicating with this resource, you're going to be calling this endpoint. And I want you to resolve the security credentials that I've set for this identifier. And what's nice about it is that you can put several ones in there, and that if you have a client key and a client secret and more of these elements to set up inside of your headers, you can set as much as you want, and the connector will be able to resolve them all and set them all up inside of your call to this resource. So over here, when we talk about data resource endpoint resolution, it's two things: grabbing the information from the contract or the resources that are involved inside the contract, and basically building the right requests with the security credentials inside of the connector in order to make this next call over here to retrieve the data. Once the data is recuperated here, we then, well, the data space connector from the provider then sends this over to the consumer, and he does a similar thing with his software, so his service, to get the endpoint to where he needs to push it, and finally push it in the data. One thing that is important to note here is that in the current model, and as for the rest, this is also subject to evolution and will be discussed in the future. But right now, as you see, this model has the data plane from the control plane relatively tightly coupled. The reason for this is mostly because the ecosystem contracts that we are enforcing and making available can have some chains that are defined in them, where, for instance, we could have one data intermediary here, one data intermediary here, and the data would go here, then here, before reaching the actual consumer. And so in order to do that, we actually need somewhere to transfer the data from the one node to another, and it's relatively hard to do if the two planes are decoupled. But really pushing on this point, this is something that is going to be discussed in the future, and is something we're looking into to make happen. All right, so this was the first data exchange flow. The second one is the one where we have personal data involved. So whenever we have personal data involved, you see that we have two new actors. The first one is the consent service over here on the data intermediary. So it's essentially the personal data intermediary. And we have, of course, the individual. The first step over here is the individual granting his consent. This, in this flow, is what is going to be triggering the actual data exchange. So it's not coming from directly a data consumer, sorry. It's coming from the individual who wants to share his data, wants to enforce the consent based on an existing contract that exists between the two participants. As before, if we want to be able to show to the individual a consent screen that is human readable and that retraces the right data that is going to be exchanged, there is the need for these two participants to have a contract, whatever the contract may be, if it's a bilateral contract or a project contract, in order to show the right information to the individual for him to grant his consent on top of. But, all right, never mind. Afterwards, so once the consent is granted, we have this check I was talking about in the beginning of my presentation. So very quick check with the contract service to validate that the contract between both is still valid. And then we have a small protocol here where the data provider is going to be generating an access token that is going to be attached to the consent and used by the consumer here to make the data request with all three information. So the signed consent, the signed contract, the consent, and the access token that was generated in order for the request to be processed and authorized over here. And then the rest of this information is exactly the same as what we've seen on the left here, except for one step here, which is basically that the provider here needs to resolve in a way or another the user identity from the consents in order to retrieve the right data for the right individual. And so just going to jump over here for 1 second to explain how this works in the current model. When a participant that has users works with a dataspace connector. He's going to be able to register his users through the dataspace connector. And the dataspace connector will be able to handle directly the registration of these users inside of the consent service. What happens is, so the participant provides the user is provided to the consent service, and the consent service generates a user identifier, which is the representation of that user for that participant inside of the dataspace. And this is important to have because this is the only way we have to identify a specific user inside a specific system inside the database. And so once we have that, the connector is able to store this information inside of his own database, because connector has its own database for a lot of things, logging purposes, storing the results of data exchanges, but also storing configuration and user information. And it will be holding, so the correlation between the user that exists in the participant and the user identifier that is known by the consent service. And now, after that, once we have this correlation that exists inside the database, well, any request that the participant wants to make for the individual based on to the consent service can be done using the user that the participant knows, and he doesn't need to worry about the user identifier that is known, that is used by the consent service in order to retrieve the right information for the right user. But so this is really just a parenthesis for this explanation, but it explains why over here we can easily resolve the user identity, because what's included inside the consent is actually the user identifier. And the user identifier is known by the connector and resolvable to the actual user identity from the participants directly. So he'll be able over here to make the right request to the right place from the resource resolution by specifying the right identity for the user. And so over here, we'll be able to know that we're going to be getting the data from that user from this data source over here. Afterwards, so same as before, the data is provided to the data consumer with the contract, but also with the consent. Sorry, I forgot to put this here. And there's the same kind of identity resolution over here in order to push the data to the right service for the right user at the end. But so essentially, the only differences in the process are a little bit of checks for the consent on top. It's a custom protocol for the consent here based on many similar flows that exist, right? For the OAuth flow, it's a little bit similar, etc. But it's just a verification step for the consent, and that the consent is granted by the user. And so this is what triggers the actual data exchange regarding personal data. Okay, lots of information. What I want to do now is show two things. I have here set up, it's going to be a little bit more technical, sorry, but it's actually something running in production, so you'll be able to see the results. So I'm going to walk you through this before I launch it. Essentially what happens here is a couple things. I want to run here a bilateral data exchange. So I'm going to be positioning myself as the data consumer, and I have the data consumer connector. I have a contract with the data provider, and I want to make this data exchange happen and make sure that the data exchange actually happened. So what I'm going to do here is the first step, I'm going to log into my connector, and I'm going to be using an endpoint of my connector to trigger a data exchange over here based on a given contract. And so in between here, I'm just going to communicate with the contract service in order to retrieve the contract information and provide it to this next phase here, which will be triggering the whole data exchange. And at the end here, I'm going to get a result that is stored inside of my connector, but also inside of the provider's connector that is synced up between the connectors, which represents some kind of object that defines how the protocol ran, if it ran correctly, etc., etc. I'm going to run it here while I'm talking because we might have a cold start, so it can take some time. But so yeah, essentially it's going to run through these steps. Actually, you're seeing it run right now. And we have a couple of things. So when we got the contract, when we went to fetch the contract, we have a bunch of information in the contract over here about who's the data provider, who's the data consumer, what's the service offering being exchanged, for what purpose the service offering is being exchanged. So this is usually the consumer side service that is provided for data processing, the negotiators, the status of the contract, etc., etc. A bunch of information about the contract. this model here is not stopped for now. It can still evolve, but it's the bare bones information that is required in order to basically be able to validate some information regarding the information that's in the contract. So afterwards, we sent this request, which was basically triggering the data exchange with the other connector. And we got at the end here, skipping to this correctly, we have here the results, basically, that is stored inside the connector, where we see that the import was a success. So as a consumer, I can see that the data exchange was successful for me. I have the reference to the contract that was used. I have this reference to what service offering was used as the purpose. I have the reference to where I can go and check the data exchange object, which should be synced up with this one at the provider's endpoints. And I have the ID of the data exchange, so the same object over here that exists on the provider's endpoint. That way, we have a correlation between both of these objects, and we have an easy way to check if something went wrong on the other side, et cetera, et cetera. But this is a first example of an actual running, because this was both of our connectors that we have hosted on Heroku that I showed before, actually exchanging data based on a contract that they had between themselves. And this is less visual, of course, than having the interfaces, but it's more representative of how it's going to be running in real scenarios, right? Usually, implementations are going to be requiring to have some specific API calls to trigger some data requests there. So it's usually going to be some machine-triggered data exchanges that happen throughout the different use cases inside of the data space. The second thing I want to show is a more complex one, but before showing this, I'm going to go back and show a more visual thing. Is showing how consent can be displayed to an individual. So here I'm on a consumer API URL, which is basically my application as a consumer. So not my connector, but some application that I have in my realm of my participants as my technical realm. And I have a bare bones here presentation that could be very well made, etc. But just for the demo, we don't have a full-fledged application for that, which basically I'm going to be providing who is the user that I want to generate a consent for, and what privacy notice ID I am providing in order to be able to retrieve the right consent. There are flows where you don't know the privacy notice ID, and if you don't, then the user will be redirected to the PDI, etc. But this is longer, and we don't have time for this. So I'm going to show this controlled demo here. But if I want to generate this privacy notice for the user for an exchange that I know wants to happen for my user, I can basically load the personal data intermediary inside of an iframe or redirect the user. This is on choice, just showing that it's very easy to integrate this inside of an existing application. And the user, me as the individual, if I position myself as the individual now, I'm going to see, because I was already logged into the personal data intermediary, so you didn't see me log in, but this is tailored for my account on the PDI. I see that this test data user participant wants to use this providing consent test data from the test data provider and wants to use it to be able to consume consent test data, which is the purpose of so the data consumer to process the data that's going to be shared to him. And as an individual, I have a very, very simple way to agree or decline this. And if I agree, it's going to be triggering the data exchange. And if I decline, it's just going to stop it, not do anything about it, and store the consent as a no inside of the consent service. So if I agree here, you're not actually going to see it in the background or anything, but consent has been stored. Consent has been sent over to the data space connectors of the participants, and the data actually has been shared. Now, in order to see something a little bit more with a little bit more data inside, this here is basically taking this exact flow and simulating it in an environment where we're actually going to be able to see the data be changed for the user from start to finish. So just to walk you through the whole sequence here, this first step in blue is not really important. It's just to set up the user and make it so that to set my user's email inside my API to something like reset@email.com, so something that we don't want to have. And after the operations from the personal data, after the operations from the data space connectors run, I will have my user at the end, which will have updated data, and actually over here, an updated email, which comes from the data provider, with whom we're exchanging data. So what happens here is that it's exactly the same process that I showed before on clicking on the agree button on my consent screen, just simulating it in a more technical controlled environment over here to see what kind of data actually outputs of this flow. So if I run this, it might take a little bit of time to start up. And I'm hoping for no demo effect, but should be fine. Okay, it's going through. Great. I have a delay here to verify that everything happens, but in the meantime, we can do is look into what happened here. So this is the output of my first setup, and we can see that I set my data for my user to have this email reset@email.com, which is not the one I want, because I know that the data that is coming from the provider is going to replace this information that I just reset for my user here. Afterwards, I simulated the ability to grant the consent for the individual, and I went and fetched the information about my user at the end of the chain. And over here, I have my email that changed to participant1@email.com, which is the one that comes from actually the data provider in this exchange. So a lot of things for actually showing just an email change, but this could be any kind of data, right? Over here, we could have missing skills, missing job profiles, missing CVs, anything that you can think of inside of the information for this user, and any kind of data that would be contractualized on and negotiated on could be shared through this protocol and injected into the results over here of our same user inside of the consumer service. So yeah, this is basically it for now. We have these two demos that are running in with our test connectors, but actually in production. I want to show very quickly before we go into the Q&A, that for example, in the Visions Trust implementation, so we have this text base that allows you to see how you configure your connector, but there's also the ability to communicate directly with the test connectors that I just showed. So by creating in one click a test bilateral agreement and then triggering a data exchange to see if data exchange actually happens. So it's a simple way it's an added bonus for onboarding new people and new participants to have an interface where they can interact with some kind of service easily and test their integration and stuff. So this, again, is something that's implementation specific, but it shows how far we can go with the implementation specific stuff, and that anybody who wants to take the Prometheus-X building blocks to build something on top of them can actually do so and build pretty much anything they want. So that's it on my side. So yeah, I mean, if anybody has questions, please feel free to ask them.
So while people, thank you very much, Felix. Great presentation. I know several have had problems to access the chat, so please raise your hand, speak up. And yeah, Justin.
Hi there. Can you hear me?
Yes.
Hi, Felix.
Yes.
Yeah, great. That's really fantastic. I was just wondering if in a project, if you have multiple providers, how do you specify which provider you want to contact for a data exchange?
Right. So This is actually, I could get deep into this, but this is defined inside of the data space connector. You have endpoints to actually trigger the data exchanges where you can specify who's the provider and who's the consumer inside of that exchange. So when you trigger that, it'll be able to look into the contract and state if both of these entities exist, then this is the one that's going to be acting as a provider, and this is the one that's going to be acting as the consumer.
And those endpoints, we get them from?
So right now,
the catalog?
Yeah, right now you have to look into your connectors docs endpoints. We're working on making this more streamlined and having a centralized Swagger for the connector that we don't have available yet. But yeah, these are information available over there.
Okay, and just what was that great tool that you were using to trace the API calls?
Postman with the flows
Postman.
feature.
Okay.
Yeah.
Thanks very much.
Hi, Felix. How are you?
Hi.
Hi, guys. About the presentation, congratulations for the presentation. It was very interesting. Here we are working a group trying to create a data space here, and we for all the studies we already did, the Prometheus-X with the concept of building blocks, it looks very interesting. But by now, my question is that we are facing some problems on setting up all the APIs, the catalog APIs, and so on to work together. Do you have a recipe, something that we can set up locally on using Kubernetes or using something or on AWS? I don't know, a recipe to set up and try, because we already accessed the GitHub, we did not have much success on that.
Well, normally you should have the information that you need inside of the repositories themselves. You have a couple options, right, to instantiate some of the components. Like as I was saying earlier, like Vision Trust, for example, just decided to host the code inside of a compute instance. You can also deploy it using Docker. You can deploy it using a Terraform script. There's a lot of options. It's really up to you to decide what you want to use. If you feel like you need more support, we can look into that offline. That's fine. But normally, with the information provided in the repositories, that should be enough for setting it up.
Great. I think that the most problem there is about the configuration files for we are a little confused about how to configure each block to work together. But okay, great. Okay. I contact you offline.
Yeah.
Thank you.
Yeah, let's work on that offline. Sure.
Yeah, that would be great. We are always looking for others to deploy it, and all your feedback on the clarity of this would be welcome. And if we can help out, that would be great. Felix, we have also a question in the chat from Irawan, where I shared the service chain protocol because Irawan wanted to know if we plan to support when there is a flow between different providers and a sequence. So I shared about the service chain protocol that's upcoming, and then there is a question about Irawan a bit more precisely on this implementation. So it will enable the project owner to define multiple entry points and different exit points for the different flows inside of one project. Not sure.
Well, not in the first version at least, but it could be something that is augmented later on. Right now, the vision for the data processing chain protocol is more to say there can be any amount of services in between two participants or any amount of providers in between two participants before the data reaches its end goal. So mostly, I think ideally, let's say ideally, we could have multiple different chains for a single project. And this would enable a project leader or participants inside the project to define, well, the entry point for one of the chains is this provider, and the output is this provider, and in between there are these services, and there could be any number of these chains that could be actionable by this protocol. But I think this is a vision for a more enhanced version. The first one is to have one chain per project. But I mean, if we have one chain per project, it's not going to be very, very hard to set up to have multiple chains supported. So I guess the short answer to your question is yes, it's going to be something that's going to be implemented, but on separate flows and not on a single flow that allow for variance of that flow.
Yeah, thanks. So first version, there can be one flow defined per project, and then we'll see for the multiple ones. Okay, any other questions? Okay, so as we said, as the next steps, I'll put the link in the chat, but we have all this great ecosystem starting to use this in the skills and education sector to build different use cases. So if you want to join it and start using this, you can, of course, go to the GitHub and start deploying your own implementations, or use Visions Trust and start exploring the catalogs and the contracts and the different use cases there, even build your own project. So yes, be welcome and reach out to us. Did you share your email or some contacts, Felix, if you have some technical questions?
Yeah, I'll share it now.
And great. And thanks a lot, Felix. It was very, very interesting and complete and clear. Great work. Have a great evening, and yeah, follow us, join us, and build it with us.